we are going to continue with physicochemical properties of building products. Physical chemistry is the study of macroscopic, atomic, subatomic, and particulate phenomena in chemical systems in terms of the principles of physics. Because all objects in nature are varied syntheses of 92 elements, the chemical composition of different objects is important in terms of relationships among each other and between different factors such as sun, atmospheric effects with products. For example, marble contains calcium carbonate and lemon contains ascorbic acid and citric acid. Calcium carbonate readily reacts with acids to form calcium ascorbate and calcium citrate, which are white. According to these relationships, the microstructures and other physical properties of building products may change. Sunlight is a portion of electromagnetic radiation given off by the sun, in particular infrared, visible, and ultraviolet light. Visible spectrum includes parts between purple 380 nanometer and red 760 nanometer rays. Rays with shorter wavelength are defined as ultraviolet. Rays with bigger wavelength are characterized as infrared, both visible and have different effects. Let's look at the nanometer. Here we have 1 centimeters, and in the insects level it's approximately 1 millimeter. The cells are 0.01 millimeter or 10 micrometers to 1 micrometer. The viruses are 0.01 micrometer or 10 nanometers, and here there are atoms. And according to the wavelength, ultraviolet radiation with shorter wavelength are like the molecules. Visible light are protozoans, and we have infrared wavelength. It's like the needle point, or we have microwave or radio waves like buildings and humans. Because of the short wavelength ultraviolet radiation, the kinetic energy of these rays are high, which can cause important disintegration and decomposition on especially organic building products. Ultraviolet rays can break cellulose in some natural materials, causing color changes, surface fractures, and degrees in mechanical strength. The infrared part of the spectrum, the long wavelength, covers the range from roughly 1 mm to 750 nanometers. Rays transferring heat energy. When building products encounters infrared radiation, due to the increase in heat energy, the temperatures of these products increase as well. According to their physical properties related to heat, these products with increasing temperature may conduct heat energy, or according to their technological properties they may deform. A chemical reaction in which the oxidation states of atoms are changed is called redox. It's the short for reduction-oxidation reaction. Any such reaction involves both a reduction process and a complementary oxidation process, two key concepts involved with electron transfer process, the transfer of electrons between chemical species. Oxidation is the loss of electrons. Reduction is the gain of electrons. Reaction can occur relatively slowly, as in the case of rust, or more quickly, as in the case of fire. During the combustion of wood, oxygen from the air is reduced, transferring electrons from the carbon. At the end of some oxidation processes, a new layer is formed on the surface of building products. If this layer has a porous and loose structure, it may destruct the product. If the layer is non-porous, it protects the structure of the product. The most common example is the oxidation of metals, forming rust or patina in different colors on the surface. Rust is an oxide formed by the redox reaction of iron and oxygen in the presence of water and humidity. Patina is a thin layer that variously forms on the surface of copper, bronze, and similar metals as a coating of various chemical compounds such as oxides formed on the surface during exposure to oxygen, rain, carbon dioxide. Corrosion is a natural process which converts a refined metal to a more chemically stable form, such as its oxide. Electrochemical oxidation of metal in reaction with oxidants such as oxygen. It's the gradual destruction of materials by chemical and/or electrochemical reaction with their environment. Rusting, the formation of iron oxides, is a well-known example of electrochemical corrosion. This type of damage typically produces oxides or salts of the original metal and results in a distinctive orange coloration. Corrosion degrades the useful properties of materials and structures, including strength, appearance, and permeability to liquids and gases. Corrosion is either uniform or it can be localized. Water and humidity can change the physical and mechanical properties of some materials or may form new chemical compounds. Water becomes acidic by dispersing carbon dioxide in the atmosphere. Many building products have alkaline properties. Because of this reason, acidic water may have chemical reactions with these products. When the water migrates to the surface of porous products and evaporates, a coating of salt will be left. This phenomenon is called efflorescence. Organisms may harm, especially organic products, by causing chemical reactions. Molds, bacteria, worms decompose organic products. For instance, wood can be decomposed into starch and cellulose and becomes dust. Fire is the rapid oxidation of a material in the exothermic chemical process of combustion, releasing heat, light, and various reaction products such as gases and particles. At a certain point in the combustion reaction, called the ignition point, flames are produced. The flame is the visible portion of the fire. Fire starts when an inflammable or a combustible material, in combination with a sufficient quantity of an oxidizer such as oxygen gas or another oxygen-rich compound, is exposed to a source of heat or ambient temperature above flash point for the fuel oxidizer mix and is able to sustain a rate of rapid oxidation that produces a chain reaction. Fire cannot exist without all of these elements in place and in right proportions. When an inflammable product is ignited, it tends to ignite other inflammable products in the same space. The fire tends to expand. If it's not controlled and extinguished, it starts to affect the walls and floors and expands to the other units through openings or may cause inflammation of other products by increasing the temperature in the neighboring units. This phenomenon depends on the combustibility of building products. Combustibility is a measure of how easily a substance will set on fire, through fire or combustion. A non-combustible material is a substance that will not ignite, burn, support combustion, or release flammable vapors when subject to fire or heat. We have a classification according to the combustibility of building products, like non-combustible. In Turkish standards, it's defined with these letters. In DIN, it's with these letters, and also we can classify them according to the production of smoke, their production of smoke, or flaming droplets, particles. Highly combustible, hardly flammable, normal flammable, and easily flammable, which are also producing smoke and flaming droplets. A fire resistance rating typically means the duration for which a passive fire protection system can withstand a standard fire resistance test. This can be quantified simply as a measure of time, like F30 means resisting for 30 minutes, resisting fire for 30 minutes. Because of the chemical reactions during the fire, the molecular structure of some products is destructed and some harmful gases are produced. The main death cause during a fire is smoke and toxic gases. In the picture, we can see the Viktor Yushchenko, the Ukrainian president poisoned by dioxin.